100 times fainter. One accidental discovery. That single number stopped the scientific community cold. A planet so dim it should have been invisible, hiding in data that had already been collected, already been filed away, already been forgotten. And here is the part that changes everything. The team that found it was not looking for it. Ben Sutcliffe and his colleagues at the University of Edinburgh were studying a completely different planet in the same system. Beta Pictoris d was just sitting there in over a decade of archival data, waiting for someone to look at the wrong thing. The star at the center of this story is Beta Pictoris, sitting about 64 light years from Earth. It is nearly twice as massive as our Sun, about 50% larger, and nearly 9 times brighter. But the detail that makes astronomers pay close attention is its age. Beta Pictoris is only about 23 million years old. Our Sun is roughly 4.6 billion. In cosmic terms, this star is a newborn. And it comes with a debris disk stretching 5 times farther out than Pluto's orbit from our Sun. A vast construction yard where planets are still being assembled. That is why this system has been one of the most studied in astronomy for decades. It is a rare, live window into how solar systems form. The research team was using the European Southern Observatory's Very Large Telescope combined with archival data from the James Webb Space Telescope. Their target was Beta Pictoris b, already one of the most famous directly imaged exoplanets ever found. Then a faint signal appeared in the data, something that did not match either of the two known planets. When the team went back through more than a decade of archival observations, the signal was there too. It had been hiding in plain sight for years. That is how Beta Pictoris d was confirmed as the faintest exoplanet ever directly photographed from Earth. Look, directly imaging any exoplanet is already one of the hardest things astronomers do. A planet orbiting a star is like photographing a firefly hovering next to a lighthouse from hundreds of kilometers away. The star's light overwhelms everything. Beta Pictoris d is 100 times fainter than Beta Pictoris b, which was already extraordinarily difficult to image. The fact that the Very Large Telescope and JWST's archival data could detect this signal at all tells you how far observational astronomy has come. With 3 directly imaged planets now confirmed in a single young system, Beta Pictoris is one of the most scientifically rich targets in exoplanet research. Direct imaging captures actual light from the planet itself. That means scientists can study its atmosphere, temperature, and composition in ways that indirect detection methods simply cannot match. 3 data points in one system, all directly observed. The study was published in the Astrophysical Journal Letters. The real work is just beginning. Subscribe if a story like this is what you came here for. The next record-breaking discovery might already be sitting on a hard drive somewhere, buried in data already collected by JWST, waiting for someone to notice a signal 100 times fainter than anything they were looking for.